And everybody. Today we have on a very pleasant and interesting discussion which is related to a right angled triangle and Pythagoras, contrasting the consideration of very numerals, and thus we are on our topic Pythagoras, a right angled theorem and the world of numbers. The theorem about the relationship of the squares on the sides of a right angled triangle, wrongly credited to Pythagoras, was known and widely used in ancient India. The so-called Pythagorean triples, giving the lengths of the side of a right angled triangle, such as in a small bracket 3, 4, 5, 5, 12, 13, 7, 24, 25, all regular three numbers are kept in small bracket, and likewise we can take in many collection of three numbers, and such type of numbers are found in the Sulva Sutras also. It is possible that, like other Hindu mathematical knowledge, they may have been developed from the other sources. They were also known, for example, in Babylon, Egypt, and China, all of which traded with India at that time. Unlike the Greeks, Hindu mathematicians were not at all disconcerted by the fact of incommensurability, that is, that certain numbers are never ending and can never be exactly calculated. Of course, it was a very interesting situation. The existence of irrational and absurd numbers upset the Greek because they were with the opinion that God created the universe from the whole numbers. God created the universe from the whole numbers. The Hindus, lacking any such ideas, had no cause for alarm. As a rule, the Hindu scholars wrote their mathematical problems in verse. They used pleasant and flattering words to encourage the student, made deliberately playful use of unimaginably large numbers, and obviously used mathematics for recreation. The love affair with figures, so different from the awe or veneration of the other people, for example, the Greek feeling that numbers were part of a sacred mystery. Numbers were part of the sacred mystery. It was the opinion of the Greeks, and which had characterized Indian mathematics, so called Hindu mathematics, from the earliest time. There were 7 Sulva Sutras, each named after the sage who composed it sometime between 800 BC to 500 BC. The sutras explain simple geometrical constructions and the theorems having to do with triangles, rectangles, and circles. They do not provide a formal systematic treatment of geometry, but are simply adjuncts to religion, nor were they built upon the latter mathematician. And the real situation was that in India, our astrologers or our ancient mathematicians, which were also astronomers, were of the opinion that nothing can be taken in mathematics as imaginary, and that is why, if we considered the equation that is x plus 1 is equal to 3, then x is equal to 3 minus 1 means 2, and that can be considered. However, whenever x square plus 1 is equal to 0, this equation was meaningless in our Indian consideration, because x will preside the two different values, and which can be taken after getting the square root of minus 1, and which was beyond our consideration. That is why the imaginary numbers or imaginary consideration for any numeral were rejected by Indian mathematician. However, Pythagoras, with respect to a right angle triangle, claimed many situations and cleared many situations also, but the reality is that this theorem was fully analyzed by Bodhayan in his Sulva Sutra in ancient India, but a formal, mathematical, and scientific expansion of the theorem was made by Pythagoras also, and this was firstly written by Euclid in his book The Elements. This ends our today lecture. In our next episode, we have to discuss another thing, and which was also very interesting at that time, but we have to put it in a new fashion and in a new modern way. Thanking you.